Hello, my dear students. Welcome to my YouTube channel. So, this is regarding alcohol, phenols, and ethers. Some of the important topics or the points I have taken here, okay, which will be helpful for your competitive exam. So, let us start with that. As I have mentioned, the preparation method, everything you might have gone through. Okay, so I'm giving some important topics from which you may get the question. So based on that one, so while reading some points you're going to miss out. Okay, by considering all those points I have made some points regarding alcohol and phenols. Okay, so let us go with that. So here alcohols, where the general formula is ROH. Okay, OH is the functional group of alcohol, and this is how you can represent CnH2n plus 1 OH. So you may get the question from this part. Okay, and there are so many methods available for the preparation of alcohol. Okay, so what happens if you know about the haloalkanes and the haloarenes? Okay, there the properties of a haloalkanes will be the preparation method for the alcohol. That is how you had to relate and you had to learn. Okay, so here what happens, alkyl halide when treated with aqueous potash gives alcohol, and when the alkyl halide treated with a moist silver oxide also gives alcohol. So it is what the reverse process of a preparation of a alkyl halide. Okay, this is how you had to relate and how you had to, and I have given so many mind maps. Okay, I'm going to mention that in the description box. You can go through that one. So those mind maps will help you to remember the reactions, the reagent. Okay, if such reagent is present, what type of a reaction it may takes place, and what might be the product that will going to form. Everything you can go through. Okay, so similarly here what we have a acetaldehyde. When an aldehyde is treated with a lithium aluminum hydride or sodium in presence of alcohol gives the respective alcohol. Okay, so lithium aluminum hydride role, what is the role of lithium aluminum hydride? It acts as a strong reducing agent. Okay, instead of that one, even you can use sodium in presence of alcohol. Okay, so similarly I have a acetone, or you can say it as a ketone. Okay, see here the aldehyde upon reduction gives primary alcohol, and the ketone upon reduction gives secondary alcohol. This is the difference you have to understand. Okay, and then we have a carboxylic acid when treated with a copper chromate also gives alcohol. Which alcohol? Primary alcohol. Okay, these points you have to remember. Okay, and now when the formaldehyde treated with a Grignard reagent, this point you have to remember. So we can prepare primary, secondary, tertiary alcohol by using a Grignard reagent. Okay, here what is happening when I use particularly formaldehyde? Okay, when the formaldehyde is treated with a Grignard reagent, primary alcohol will be formed. Sorry. Okay, yeah, when what I can say, other than formaldehyde, if I use acetaldehyde, propanaldehyde, okay, so those aldehyde gives secondary alcohol and the ketones will give tertiary alcohol. Okay, that you had to remember. So difference I'm saying. So if I say formaldehyde, don't think that it will going to give a secondary alcohol. No, because there is a absence of a one methyl group over here. We have only hydrogen. So obviously it results in the formation of a primary alcohol. Okay, so similarly there is one standard method of preparation. Okay, that is hydroboration oxidation reaction. You might have practiced this one. Okay, so the question that appears over here is, see, it's quite simple. The method follows like when a propene is propene. Okay, that is when an alkene is treated with a diborane followed by a oxidation in presence of a hydrogen peroxide, it results in the formation of a alcohol. Okay, that is a mono substituted or primary alcohol. Here this hydroboration oxidation method will going to follow which rule? The question will appear based on this one. Okay, so you have to remember this method follows Markovnikov's rule. Okay, so that is a secondary substitute. Sorry, I told you that it's a primary alcohol. So but in case of a hydroboration oxidation reaction, it will going to follow Markovnikov's rule, means we'll going to get the respective secondary substituted alcohol. Okay, so which rule? It will going to follow Markovnikov's rule, that you have to remember. Okay, so similarly there is another important, that is oxymercuration demercuration reaction, where we have an alkene when treated with a mercuric acetate in presence of a water. This is very important. Okay, multiple step it will go into take, and finally it results in the formation of the secondary alcohol, and even this also follows the Markovnikov's rule that you have to remember. Okay, now there comes another process called oxo process, which can also be known as a carbonylation or hydroformylation. Okay, so here we have a alkene when treated with the carbon monoxide followed by the hydrolysis results in the formation of with a multiple step to give a respective alcohol. This process you have to remember. Okay, and all the reagent, dear students, you have to remember. Now some of the physical properties that the boiling point of alcohol are much higher than the corresponding aliphatic hydrocarbons and the haloalkanes. Okay, see, when it comes to the alcohol, they will be having a more boiling point. What is the reason of higher boiling point than the hydrocarbon and the haloalkanes is, here what happens in case of alcohol, we will be having a OH group. Okay, so what happens, there is a formation of a, what I can say, the hydrogen bond with one another OH group. Okay, so intermolecular hydrogen bonding you could say. Okay, that results in the higher boiling point for the alcohols compared to hydrocarbons and the haloalkanes. Okay, and now when the like among isomeric alcohol, like a primary, secondary. Okay, so what happens, the boiling point decreases with a branching due to corresponding decrease in a surface area. That is, boiling point decreases in the order of primary, secondary, tertiary. Okay, primary will be having a more boiling point followed by secondary followed by tertiary. Okay, tertiary will be having a very less a boiling point compared to these two, because it's quite simple. What happens, the boiling point decreases with a branching due to corresponding decrease in a surface area. Okay, that's a point you have to remember. Now solubility, yes, alcohols are soluble in water. Okay, so why? Because they are able to form the hydrogen bond with a water molecule. That is what we have learned. Okay, but what happens, the lower alcohols are highly soluble, but as the molecular mass of the alcohol increases, the solubility goes on decreasing, because the hydrophobic part will go on increasing. Because as the molecular mass increases, it doesn't mean that the number of carbon atom increases. So as the carbon atom increases, that hates water and the hydrophobic part increases. So obviously the solubility goes on decreasing. Okay, and then the reaction in which OH bond cleaves. Okay, see what happens when we consider the chemical properties of alcohol, they'll undergo in two methods. One is, here I'm going to write, it involves the breaking of a OH bond. So the chemical reaction will going to take place, and it involves the breaking of a RO bond. R is nothing but what? Carbon. So what happens? The cleavage will happens in two ways. Okay, so based on that one, in such acidic, if the bond is breaking, like if the OH bond is getting cleaved, here what happens, in such acidic behavior reactions, the reactivity order of alcohol is primary, secondary, followed by tertiary. Okay, but when the CO bond breaks, okay, the order of a reactivity is tertiary is highly reactive followed by secondary and primary. So this is a difference you have to remember, and they may ask you question based on this one also. Now next comes where I have a primary, secondary and the tertiary alcohol, where all the alcohol, if they are colorless, how you can distinguish that one? Okay, so you can differentiate, you can distinguish by using a Lucas test. Okay, what is Lucas? Reagent anhydrous zinc chloride in presence of a concentrated HCl. So what is the role of anhydrous zinc chloride? I have already told in the previous video. You can check that one. Okay, so here what happens, when this reagent is treated with a tertiary alcohol, I'll going to get immediate turbidity or precipitation. Okay, when it is treated with a secondary alcohol, the turbidity appears but after some times. Okay, when it is treated with a primary alcohols, in a normal condition, no reaction you could see. If the reaction means the reaction is going to happen only upon heating. Okay, this is how you can distinguish between the primary, secondary and the tertiary. You may get the question based on this one. Okay, now this is very important. Primary alcohols, when treated with a copper or silver, Okay, in the temperature around 573 Kelvin, it will undergo dehydrogenation. What do you mean by dehydrogenation? That is the removal of a hydrogen. So there is a lot of difference between the dehydrogenation and dehydrolysis. Okay, dehydrogenation, removal of a hydrogen, that results in the formation of an aldehyde. But even the secondary alcohols, when treated with a copper under 573 Kelvin, here also dehydrogenation takes place, that results in the formation of a ketone. So what the difference you had to see here is, primary alcohol upon dehydrogenation gives aldehyde, secondary alcohol upon dehydrogenation gives ketone. Okay, but if I take a tertiary alcohol, if I treat that with a copper or silver at this temperature, what happens? We cannot expect dehydrogenation. Okay, why? Because in tertiary alcohol already there is the absence of a tertiary hydrogen atom, where we had a secondary hydrogen atom, we had a primary hydrogen atom, so dehydrogenation have taken place. But when it comes to a tertiary alcohol, there is an absence of a tertiary hydrogen atom. So what happens? Tertiary alcohol will undergo dehydrolysis, means a water molecule is eliminated, that results in the formation of an alkene. That's the difference you have to consider. So tertiary alcohol upon treatment with a copper under this temperature always gives alkene. Okay, but the secondary alcohol gives ketone and the primary one gives aldehyde. So this is a very important reaction where you have to consider this point, especially regarding the tertiary alcohol. So when it comes to alcohol, we will going to see a different type of alcohol, like denatured spirit. Okay, we will going to call it as a spirit. That what are the content or what are the composition of those different type of alcohol we're going to use. So when I say denatured spirit, which is unfit for the drinking, why? Because it consists of ethyl alcohol, along with that one 5 to 10% of a methyl alcohol. Okay, what is power alcohol? 80% of a petrol, and along with that one 20% of absolute ethyl alcohol. Okay, you might have heard this word like a power petrol. Okay, why? Because it consists of a 20% of ethyl alcohol along with the petrol. Okay, when it comes to order of acidity, see, we will say alcohol is least acidic. Okay, so when I consider the order of acidity of a water and the primary, secondary, tertiary alcohol, this is what the order you had to remember. So you could see among all, water is highly acidic, followed by a primary, secondary, tertiary, alkyne, alkene, then alkane. Okay, so this is about the alcohol, some important points that I have taken. Next comes phenols. So when I say phenols, yes, so here we have a benzene ring. Along with that one, there is a presence of a OH group. This is what we're going to call it as a phenol. So we're going to study this phenol under separate heading, as you all know. So when I say phenol, they are a weak acid. Okay, so phenol reacts with the active metal to give hydrogen, reacts with the alkali to give salt and water, and turns blue litmus to red. When I'm saying phenol is acidic, obviously when I treat that phenol with any active metal, it should liberate hydrogen. Okay, when I allow it to treat with any base, it should give salt and water. Okay, when I put a blue litmus on that one, it should turn that blue litmus into a red. Okay, from all this reaction, I could say phenol is acidic in nature. Okay, now between the phenol and the phenoxide ion, how phenoxide ion is formed? When phenol will undergo ionization, that results in the formation of a phenoxide ion with the liberation of a H plus ion. Okay, so when I compare with the stability of a phenoxide ion and the phenol, always phenoxide ion is highly stable than phenol. Why? Because the more resonant structure you could see in a phenoxide ion than phenol. So this is another important point that you have to consider. And next, when it comes to a substitution, like we have a nitro group, we have a cyanide, we have a halogen, and we have a aldehyde. All these groups are considered as an electron withdrawing group. Okay, so when such groups are attached to the phenol, what happens to its acidity? So always you have to keep this point in your mind, that whenever electron withdrawing group is attached, the acidity of any compound increases. Okay, so but when it comes to electron donating group, so for example alkyl, alkoxy, amine, such group are what? They are the electron donating group. So always those electron donating group will decreases the acidity of any compound, here particularly for the phenol. Okay, that another point you have to consider, and many questions will appear based on these two concepts. Next one is the aqueous solution of a phenol is nothing but, or it is called as a carbolic acid. Okay, so this is another point you have to give importance. At last they're going to ask you the comparison of acidic strength. So when I say cresol, phenol, parachlorophenol, metanitrophenol, orthonitrophenol and paranitrophenol followed by picric acid. What is picric acid? It's a 2,4,6 trinitrophenol. Okay, so when they give you a comparison, like when they ask you the comparison regarding all the acidic strength of these, you should be aware. When I say cresol, it consists of a methyl group. So as I already mentioned, the methyl group is an electron donating group. Obviously what happens? It decreases the acidity. So here you could see the arrangement. Cresol is weak acid than phenol. Okay, phenol is weak acid than parachlorophenol. Why? Because in case of a parachlorophenol, I have a chloro group which is electron withdrawing group. Okay, so that's why parachlorophenol is more acidic than phenol. Okay, followed by like when I say parachlorophenol and metanitrophenol, metanitrophenol is highly acidic than parachloro. Why? Because a nitro group is a strong electron withdrawing group compared to a chloro. Similarly, orthonitrophenol followed by paranitrophenol. At last, the more acidic phenol, if I say, is that is picric acid, or I could say 2,4,6 trinitrophenol. Why? Because it consists of a 3 electron withdrawing group. As the electron withdrawing group increases, obviously the acidic nature also increases. That's a one point. And another one point, even you can explain the acidic nature by considering the pKa value. Okay, that is potence of dissociation constant of an acid. Okay, so how it is related? It is inversely proportional to the acidic nature. Okay, if the value, what is pKa? It's simply a number. Okay, so if the number is more, then acidic property will be less because they are inversely proportional. Okay, so what happens if I say cresol and phenol? If I compare, what happens? As you all know, cresol is weak acid. If it is a weak acid, it will be having a pKa value more. Okay, so here if phenol has some pKa value which is lesser than the value of a cresol, then phenol is highly